Question 466. Evaluate indefinite integrals. Okay, if we have a fraction and if we have only one term in our denominator, then we can always separate these numerators. Okay, so x cubed over x squared minus 2x squared over x squared plus 2 over x squared. Just like that. Okay, let's simplify this. So we have integral x cubed over x squared minus 2x squared over x squared plus 2 over x squared. So we have 3 separate terms, right? So let's simplify this. X cubed over x squared, that's x. 2x squared over x squared, that's a 2. Plus we have a 2 over x squared. That's actually, it can be written as 2 times x to the power of negative 2. Right? So let's find the antiderivative of this and this and this term separately. So x becomes x squared over 2, right? Minus 2x, because the derivative of 2x is equal to, plus 2x to the power of, we have to add 1, right? So negative 2 plus 1, negative 1, over negative 1, this number right here, right? And after we find our antiderivative, we have to have c, constant c here, right? So that's going to be equal to x squared over 2 minus 2x. Here we have a minus 1, right? So minus 2 over x to the power of negative 1, that's 1 over x. So 2 over x plus c. That's our answer. Question 468. We have 2 separate terms right here. And both of these terms have a square root. They're in radical form, right? If we have radical form in our integrand, then change that into exponent form first. Okay, that's the key. So let's try this. We have integral. Here, square root of x, that's x to the power of 1/2, right? What about this? This is 1 over x to the power of 1/2. So that is equal to x to the negative 1/2, right? So we have a plus x to the negative 1/2. So far so good. Now let's find the antiderivative of each term. So x to the power of 1/2, x to the 1/2 plus 1, right? So that's going to be 3 over 2 over this number has to go down here, right? So 3 over 2. So far so good. Plus x to the negative 1/2 plus 1, that's positive 1/2. So write positive 1/2 down here. And we have to add c, right? If we have a fraction in our denominator, what we can do is we can switch these two numbers and multiply that number to this expression right here. Okay, so switch it, flip it. 3 over 2 becomes a 2 over 3, right? So 2 over 3 times x to the power of 3 over 2. If we switch these two, that's going to be 2, right? So plus 2 times x to the power of 1/2. And we have constant c, right? We can leave our antiderivative in this form right here, or we can change this expression into radical form. Okay, if we rewrite this expression in radical form, that's going to be 2 over 3. Here, over 2, that's a square root, right? Square root x cubed, right? So we have x cubed here plus 2 square root x to the power of 1. That's just x, right? and plus c. Now we're done. Question 473. We have indefinite integral with a 5 over 1 plus x squared, right? Remember, the derivative of inverse tangent was equal to 1 over 1 plus x squared, right? So this indefinite integral can be written as 5 times integral 1 over 1 plus x squared dx, right? So antiderivative of this expression is equal to inverse tangent x, right? So this is equal to 5 times inverse tangent x plus c, right? Question 479. Here we have only one term in denominator, right? So we can separate this numerator into two separate terms, sine over cosine squared plus 1 over cosine squared. Okay? So integral sine x over cosine square x plus 1 over cosine square x. Okay? What's sine over cosine? From trigonometry, we know that sine over cosine is equal to tangent. And what's 1 over cosine? 1 over cosine is secant x, right? And we also know that derivative of secant is equal to secant tangent, and derivative of tangent is equal to secant square, right? So far so good. So let's simplify this. That's gonna be here sine x over cosine x times 1 over cosine x plus 1 over cosine squared, that's secant square, right? So we have sine over cosine, that's tangent. 1 over cosine, that's a secant. Plus secant square, right? So antiderivative of tangent x secant x, that's secant x, right? Antiderivative of secant square x, that's going to be tangent, right? So antiderivative of a tangent times a secant, that's secant x. Antiderivative of a secant square, that's tangent. And we have that c, constant c, right? Question 482. Which of the following could be an antiderivative of e to the power of 2x minus natural log 5? In order to find an antiderivative of this expression right here, we're going to have to integrate this, right? So here, indefinite integral with the e to the 2x minus natural log 5 dx. That's what we're looking for, right? What function do we have to have here so that its derivative is equal to e to the 2x? That's 1/2 times e to the 2x, right? Because when we differentiate e to the 2x, let's differentiate this. We're going to have e to the 2x times 2, right? By chain rule, right? So we must have 1/2 here, so that its derivative is equal to e to the 2x, right? So antiderivative of e to the 2x must be equal to 1/2 times e to the 2x. In reverse, derivative of this is equal to e to the 2x, right? Derivative of this is equal to e to the 2x. Does that make sense? Okay. Here we have natural log 5. That's constant, right? That's constant. So antiderivative of natural log 5 is natural log 5 times x, right? The derivative of this expression right here, this is constant, right? So derivative of this is just equal to natural log 5. So far so good? Now, since we found our antiderivative of this expression right here, we must add c, right? Constant c. So our answer has to be 1/2 e to the 2x minus natural log 5 times x plus some constant c. Okay, so the answer has to be c, right? So the answer has to be c. Does that make sense? Question 484. The function f has a slope of this expression at each point x, y on the graph of f. If the graph of f passes through the point 1, 2, what is the equation of f? Here it says f has a slope of this expression right here, which means this is equal to f prime of x, right? So we have f prime of x is equal to x plus 2 times 2 minus 3x. If we expand this, x times negative 3x, that's negative 3x squared. And x times 2, that's 2x. 2 times minus 3x, that's minus 6x. So minus 4x. And 2 times 2 gives us 4. Right? Okay, the question here is, if the graph of f passes through this point right here, what is the equation of f, right? Here we have f prime. The question is to find f. So we're going to have to integrate this f prime, right? So let's integrate this. Negative 3x squared minus 4x plus 4 dx. This is going to be our f, right? And if we find the antiderivative of this f prime, that's going to be negative 3x 2 plus 1, 3 over 3 minus 4 times x 1 plus 1, 2 over 2 plus, we have constant 4, so we must have a 4x and plus a c, right? So if we simplify this, that's going to be, cancel this one out. This becomes 2, right? So negative x cubed minus 2x squared plus 4x plus c, right? That's f of x. And here it says f passes through the point 1, 2, right? Which means when x is 1, y is equal to, right? So 2 is equal to negative 1 minus 2 plus 4 plus c. So 2 is equal to, here negative 3 plus 4, that's positive 1, right? So c is equal to 1. So finally, our f of x is equal to then negative x cubed minus 2x squared plus 4x plus 1, right?